Hey everybody, welcome back to another video within the system design series, and in this video we'll be talking about designing TikTok. Now most of you might already be very well accustomed with the platform itself, but in case you have to build something similar, then this video would be exploring all those essential components that you should have within your architectural belt, and so that you can take care of, some of the recurring scenarios. So let's dig into it. Let's talk about some high level requirements. We'll not cover all of them, but we'll cover the majority of them. So the very first point would be requirements. All right, so the very first requirement would obviously be creating short videos. Create short videos. 15 seconds to be minimum, can span up to 1 minute. The second requirement would be the engagement part of the videos. By engagement, I mean liking a particular video, commenting, sharing, all that stuff. We can also include reporting over here. The third point would be searching the video. The fourth point would be localized content. Perfect. So we have our requirements perfectly laid out. But whenever you're building an architecture, whenever you're proposing a particular architecture, you would need some sort of metrics to sort of evaluate your architecture according to it. And these metrics, let's lay a few out. We need the scalability metric. We need the availability metric. Availability. We need reliability metric. We need fault tolerance. And the fifth one would be encryption. So before we sort of propose our final design, we'll be making sure that we are covering all these 5 metrics within our architecture. Now, before you begin laying out the solution, it's always wise to talk about numbers and inquire about those numbers from the interviewer, because it gives a really good impression that you're taking care of those numbers in your head. You're making sure that what kind of request count what your services would be exposed to, what kind of storage capacity are you dealing with. So all those things can only be computed once you have numbers. So in this particular case, let's assume that TikTok, let's say daily stats. Let's say TikTok has like 300 million users per month. And let's assume that the number of daily active users is around daily active users is around 800K. And the number of video uploads per day by these users, daily video uploads would be like 4. Let's assume 4 to 5. And size of each video. Size. So this would be somewhere around, again, 4 to 5 MB. Perfect. So now we need total storage per day. So let's evaluate that. total storage per day. So that would evaluate to 800K into 4 into, yeah, let's say 4 MB. So this evaluates up to 13 terabytes. That's quite a number. All right. But whenever you're proposing a particular architecture, it's always wise to not stay confined to the problem at hand, but it's always wise to sort of project that problem up to 5 years. So whenever you're proposing an architecture, make sure that it can sort of say solid and bulletproof till 5 years. So how we can compute that is simply through, let's say, total. So this is 13 terabytes into 365 days, and it evaluates up to somewhere around 23 petabytes. Yikes. Now this can be a deciding factor whenever you're talking about choosing a relational database or a NoSQL database or a blob storage, because that's a huge amount, and this amount of data would keep on increasing with time. So we have to make sure that we make a choice that is cheaper and economical for our team and the company in a future, in terms of the future prospects. So let's talk about it a bit later. So we have our requirements, we have our evaluation metrics, we have our daily stats. Let's get into the solution now. Perfect. So let's start with the scalability. Obviously, we need some sort of a factor where we divide our functionality into micro functionalities, or in more technological terms, if we divide our functionality into microservices, because so a lot is happening here. So we are uploading content, we are watching content, we are updating that content, we might be deleting some of our content, we are engaging with different other contents. So a lot is happening. And if we just go with one service, it's not going to be a wise approach. It's not going to be a scalable approach, because we'll be putting in all the load in our, into one instance, which eventually would blow up. And once it blow up, then you're down with two choices: either to vertically scale it, add more RAM, CPU, and some hardware, components to it, increase, which would definitely have a significant, impact on your cost, because you can't just go this way. You can't just, put in, hardware components into your servers. You can't just buy, a higher instance, because all those higher instances aren't cheaper. So you have to think about horizontal scaling approaches. But for that, it's very crucial that you divide your functionality into multiple services. So in this case, I would say that I have a service. Let's say services. Let's scroll this up. So we have an upload service. Then we have a watch video service. And third, we have, an engagement service. So now we have this functionality divided. Now we can make sure that, which service which would be used, in a more disruptive way. And I can easily say that the watch video service would obviously, would be the most accessed service. So let's just design our user over here, which would be a mobile client. All right. Now, what's the deal? Do we actually just point all of our traffic to these services individually? No, obviously not. That won't be a wise approach either, because our load would never be divided into it. So we need some kind of a load balancer sitting in front of all of these services. So let's say, let's add a load balancer over here, balancer, and our incoming traffic is coming right this way, down this way to our service components. So let's draw in 3 different hooks over here, and I'm gonna add my service boxes over here. Let me scroll this up. All right, this one would be upload. This one would be watch. This one would be engagement. So one part of scalability is addressed through using a load balancer, but we won't be keeping like individual services over here. Obviously, we need multiple services running at the time. So we have a load balancer and multiple other services, which can be encapsulated into a auto-scaling group. Let me draw a square out of these, just like that. Okay, this one's tricky. Okay, I'm just gonna do it anyway. Okay, perfect. So this would be my auto-scaling group. So obviously, we can decide on a number. When you see these services over here, all 3 of them, the ones, it's kind of hard to decide that which one's the most crucial one. Obviously, since a lot of people would be just scrolling through the application, hence we can say that, you know, the watch video service would be the most disruptive service, or the one service that would have a lot of incoming traffic. But still, I mean, there would be times in a day when the upload service might be the most disruptive service, or sometimes maybe the engagement service is the most disruptive service. So we cannot think of a particular number which we can set that, okay, we need these much instances of upload, watch, or engagement service. So it's wise to have a auto-scaling group wrapped around them, which would take care of the fact that whenever there's kind of high traffic for each of these services, it would scale up and scale down as per requirement. So that's one less problem for us. So, and this also solves another scalability metric issue. So I believe in terms of scalability, we're good to go. We can talk about availability first. Obviously, having services in, you know, multiple AZs or, you know, multiple regions can help. Because let's say if you have something going on within one region or one availability zone, then having your services scattered into multiple availability zones can help. You know, in that case, you're always available, and you're never going down. And if in case of, you know, it can also help you in terms of fault tolerance, because if your one service goes down, there's always one running in a different availability zone. So let's talk a bit more about it, because we're gonna wrap up the storage into this argument as well. So the daily stat says that we have like 23 petabytes of 5 years projection, and we have our daily storage of like 13 terabytes, which is a lot of data. Now, whenever we talk about storing this data, we have 3 or 4 options. Obviously, one of them is relational database, one of them is blob storage, one of them is keeping some of our data or all of our data into a NoSQL database. We have memory databases as well, but in this particular scenario, we're talking about storing the actual videos. Now, if you're talking about 13 terabytes per day, obviously storing it into a relational database would not be wise, because some of these relational databases aren't built for this scale of data. And especially whenever you're keeping your data in a normalized manner, you would be, welcoming a lot of joins, which would obviously be a factor of concern in terms of, storage capacity, in terms of performance, in terms of latency, in terms of queuing and whatnot. And things are just going to get complicated. So obviously, the best option would be to use a blob storage, something like S3, which is cheaper and it sort of scales up to exabytes of data, which in our case seems like the most promising option. So let's say whenever you upload your data, it goes straight into an S3 bucket. Obviously, having S3 really helps because it's a service that has a global scale, and it really helps in scalability. It helps you in availability, and in terms of reliability, it has like 11 nines in terms of durability. So it's like 99.999 up to 11 nines. So when we're speaking of losing your data, this might come handy whenever we're talking about the factor of reliability. So it helps. But obviously, we won't be storing all of our data into S3. We're just talking about blobs over here, keeping our videos over here. But there's a lot of content that is associated with your video, like the title of the video, timestamps, length of the video, if you have used any hashtags, if you have tagged anyone. So all of that data, which can be considered as metadata, can be stored into a relational database or even a NoSQL database. It's your option. It's your preference, really. I don't mind storing it into relational database, because if we have to make sense of some of the data, and especially in terms of when you've tagged somebody, and obviously you need some sort of relation over there, so this might help. So we can say metadata. Perfect. So in terms of availability of both of these, as we have said, that S3 has a global scale, and if you're storing metadata, we can think about read replicas that can reside into different regions. The quantity depends, obviously. So we can say read replicas. These can be multi-AZ as well, residing into multiple availability zones / region. It's your call. So this sort of solves certain factors of reliability and being available. All right. And also fault tolerance in some capacity. So I think we're done in terms of uploading stuff. Let's talk about watch video. Obviously, the very first guess is that obviously it would be retrieving data from the blob storage over here and the metadata over here. Obviously, there would be some queuing involved within the metadata layer, and some fetching involved in the blob storage layer. Can we make it quicker? Because let's say when we have like that much active daily users, we have to make sure that performance and latency is crucial at this stage when we're fetching the data. So one good thing can be that we use a CDN. in front of retrieving data from, you know, both S3, and we can also store some metadata over here. So let me just draw a arrow from watch to CDN. Also, we stated that we have a requirement of localized content right over here. Oops, I just went way too far. So yeah, localized content. So we can handle this pretty much in a very easy manner through our CDNs. We can also make sure that, you know, if you don't want to serve a certain kind of content or a category of content to a particular country, obviously we can handle it from here. Perfect. So in terms of latency, we have solved the problem by adding a CDN. We have our multi-AZ metadata database. We have the blob storage. We're good to go in terms of, I believe, scalability, availability, reliability, and some aspect of fault tolerance as well. Also, to make it even more quicker, we can use some form of a, let's say, we can add a layer over here, which is a layer of a cache or an in-memory database, which can sort of help you retrieve content even more quickly. Obviously, we'll be following some sort of a cache writing method over here, which would be a write-through method. So the write-through method ensures that whenever you're writing to the database, you're also writing it through the cache so that it's readily available once it has been written into the database. So it's like one more added layer of reduced latency. Finally, let's talk about the engagement service. Obviously, we have different kind of functionalities involved over here. We're talking about liking the content, commenting on the content, and obviously all of this would be generating some form of, you know, notifications and stuff. So it would readily be writing through, let's say, let me just add dotted lines while going through the CDN, and we can say right over here, and it would be replicated over here, or if it's, so yeah, something like this. So since metadata holds most of our data about a video, tag people, and we can store some form of, you know, likes, comments, and, you know, the number of shares, all that kind of stats about a video over here. So it would be engaging more with these databases. Also, it would be generating some sort of a service. So we can have another layer of a service, and it can have multiple instances, and it can have its own. The engagement service would directly be talking to notification service, which obviously would in some way or format accessing the content within the CDN and the metadata itself. I should have given it a different color, but you get the idea. So yeah, I believe we have covered quite a lot of ground here. All right, let's talk about encryption. So when we're talking about encryption in a blob, so we have the functionality of, you know, encryption at rest, and obviously our mobile client would be TLS supportive. So all of our communication at transit would be secure, and at rest we have encryption within the blob storage, and we can activate encryption at rest over our metadata as well. Perfect. And the blobs, and especially S3, you can have You can sort of leverage around using pre-signed URLs if you're really concerned about the security and the sensitivity of the content. So that's also something that we can play around with to ensure that, our content is secure and securely transferred to the user. Perfect. So let's say this is done as well. So this is like a high level scenario of, some of the majority of the use case of the TikTok application and how we can sort of reach to the conclusion of where to store and what to store within our databases or our blob storage. So yeah, let me know what do you feel about it, and if you have any questions, please add them into the comment section. If you have any suggestions, again, since this is a high level architecture, it might have some missing elements and missing components. So if you feel like some of them are worth mentioning, please do mention them in the comment section. Thank you so much, and I'll see you in the next video.